Hi, my name is Helen and I'm studying for an MSc in Advanced Mechanical Engineering. For my group project, we studied offshore wind turbines. In particular, we looked at the foundations of offshore wind turbines and how one should connect two components of that foundation, one being the monopile, which is driven into the seabed, and the other being a section called the transition piece, which sits on top of the monopile. We reviewed a range of existing technologies for connecting those two parts of the foundation and also looked at some new innovative technologies as well. In particular, we looked at a design called the wedge connection. We did some detailed analysis including generating fatigue curves, doing some finite element modelling and some analytical analysis as well, and that found that the wedge connection is a really exciting design which has quite a superior fatigue life in the loading conditions of an offshore wind farm as compared with one of the existing technologies. And we also managed to optimise some of the design parameters as well, such as the number of connections in a single foundation. For my individual thesis, I'm developing a methodology for describing the process of corrosion fatigue. Fatigue is the process by which structures get damaged through the repeated cyclic application of forces or loads. And although each one of those individual forces or loads might be much lower than the level required to cause significant damage to the structure, the repeated application of these low-level loads cause a crack to form and propagate. And then corrosion fatigue is that same process that happens in a corrosive environment, which accelerates that damage process. So I'm looking at developing a kind of methodology or a model to really accurately describe and predict that process. So I'm currently undertaking a literature review of existing corrosion fatigue models, and then we'll be looking at experimental data in order to develop an improved version of that. After I finish studying here at Cranfield, I will be taking up a role at Siemens, where I will be working on the team developing the 3D modelling toolkit Parasolid. Parasolid is a geometric kernel which underpins a large number of software packages, which are generally computer-aided design or computer-aided manufacturing software packages, which are widely used across a huge range of engineering applications.